Hey all, Dr. Danju here again. Today, we're going to be covering chapters 13. All right, and in chapters 13, we're looking at ANOVA, analysis of variance. Yes, I know we did an hypothesis test for variance, but this is different. This is ANOVA, an analysis of variance, meaning that we're looking at different averages and seeing if there's a variation in the averages. Yeah. So it's slightly different, but it follows the same principles of hypothesis testing. Let's go, let's go, let's go. So what I'm going to do today is we're going to do a quick review. Then we're going to actually jump into our lecture, and then we're going to complete chapters 13. So follow along. Hopefully this makes sense to you. Once again, my head is going to be in a swivel. I will share my screen with you all. All right, and we are going to get this going. All right. So hopefully you can see my screen right here. All is good. All right. We're going to be looking at chapters 13 in week 13. Yeah. All right. But first off, I would like for us to go into our lecture for today. ANOVA, analysis of variance. But let's do a quick recap. In chapters 12, we actually did three hypothesis testing. The first one was the goodness of fit. In the name itself, it tells you what the null hypothesis is. It is a good fit, all right? But if you see rejected, all right, let me get my laser up in here. It means that these observed frequencies are not a good fit. All right. Then we talked about the test for independence. Ultimately, the null hypothesis is that these two variables are independent of each other. If it says rejected, it means that they are not independent. Last but not least, we covered multiple proportions, hypothesis tests for multiple proportions. What we're checking here is to see, are these proportions equal? That is your null hypothesis. All of them are equal. But if one or more is not equal, then we would see rejected, and it means that at least one proportion is not equal. All right, so now that we got that out the way, now let's jump into our lecture for today. ANOVA, analysis of variance. What we're looking at is different groups and subgroups to see, are they equal or not? Is there overwhelming evidence that these groups or subgroups are not equal? So, like, you know what I always like to do? I always like to come from a Christian worldview perspective. And today, I'm going to be coming from different groups, all right, different subgroups. So, my question to you all is this: how does God see different groups and subgroups of people, of nations? Does God see Jews better than Gentiles? Does God see, some kind of religion better than the other? Or does God see them as people and God reaches out to people no matter what background you come from? All right, good. Once again, use this information. All right, excuse me. All right, use this information to help you make informed decisions. All right, so how does God see different groups and subgroups of people? You guys can use this information and make informed decisions and see what answers you get out of basically the storyline that I'm going to be sharing with you today. All right, so we're going to be using these two characters right here. This guy is going to represent Philip. This guy is going to represent an Ethiopian. Philip is a Christian who is now converted, is was an actual Jew and is now converted into a Christian. The Ethiopian eunuch is looking for God. All right. So the question is, how does God see different groups and subgroups of people? Does God only care for the Jew or for the Christian, or does God care for everyone. All right. Hopefully by now you should know that God cares for everyone. But here it was that this Ethiopian eunuch heard about the things of God and went to Israel looking for God. He went to the temple and he didn't actually find God there, but he left with the scrolls. And as he was heading back home to Ethiopia, he was reading the scrolls. All right. As all this stuff was going on, God spoke to Philip. God said to Philip, "Look here, man, I need you to get up and go." He didn't know where he was going. He just followed God. So as he was going, God led him to the Ethiopian. And as God led him to the Ethiopian, he heard the Ethiopian reading. God said to him, "Go up to the Ethiopian, listen to what he's saying." And as the guy is reading the scrolls, he could not understand what the scriptures were saying. And oh, by the way, the scriptures, what he was reading was that Jesus was basically going to come and die for all of our sins. All right. And Philip went and said, "Do you understand what you're reading?" All right. Now, just imagine if you're from a different race, a different background, and someone says, "Man, can you read? Or do you know what you're reading?" How would that come over? All right. But in this case, the Ethiopian was like, "Man, how can I understand unless someone explains it to me?" All right. So Philip explained the scripture verses to him and explained that Jesus came for all people. And the Ethiopian was so excited to hear that. He saw some water and he was like, "What is stopping me from being baptized?" And Philip explained to him, "All you have to do is believe in Christ and you can be baptized." And this is where the story picks up right here. All right, in Acts 8:39. Now, when they came up out of the water, the Spirit of the Lord caught Philip away so that the eunuch saw him no more. Imagine for but a second if you're being baptized, the person who baptized you dips you down in the water, and when you come up, that person is gone. That person has disappeared. That is what this experience, this Ethiopian eunuch experienced when Philip baptized him. Dipped him down in the water. When he came up, he was gone. Now, instead of the eunuch being shocked that this is actually happening, he went on his way rejoicing. He actually got a real life experience of God's power, of God's love, of God's grace right there and then. First off, God sent Philip because God was talking to Philip, knowing exactly what this eunuch was experiencing. Could it be possible that God cares for everyone, whether they're Indian, whether they are whatever religious background they're coming from, Muslim, whatever it is? Could it be possible that God cares for all groups and subgroups of people? I would say there's overwhelming evidence that that is true. But today, what we're using is ANOVA, analysis of variance, to look at different groups and subgroups to see if they're equal or not. If one or more of your groups are not equal, then it would say rejected. At least one of these groups or subgroups is not equal. All right. So what will we learn today? We're going to learn all these things right here. But for the most part, all right, experimental designs and analysis of variance. All right. So statistical studies can be classified as being either experimental or observational. All right, some kind of test, some kind of observation. All right, good, good, good. In an experimental study, one or more factors are controlled. All right, so when we do some kind of experiment, we can control one or more factors. Good. In an observational study, no attempt is made to control any of the factors. All right. So it just happens naturally, and we're just observing it to make sure that we document what we have observed. All right. So you got two types of studies. Cause and effect relationships are easier to establish in experimental studies than in observational studies. All right. That's very important to know because some tests only works for observational, some tests only works for experimental. But the cool part about ANOVA works for both. All right, can be used to analyze the data obtained from experimental and observational studies. So ANOVA is really good. We're looking at different averages of groups and subgroups to determine are they equal or not. All right. So what does it actually look like? The null hypothesis means that they're all equal. All these groups, all these subgroups are equal. It doesn't matter your religious background. It doesn't matter your economical status. It doesn't matter any of all of that stuff. God cares for all groups and subgroups of people. All right. There should be overwhelming evidence that the null hypothesis is true. But if you or if someone can find one example that God doesn't care for all groups and subgroups of people, then you can say rejected. Not all the population means are equal. If one or more are not equal, it is going to be rejected. It will mean that not all the population means are equal. So now that you got that concept in your head, we in Excel can do a data analysis, ANOVA single factor. We can do a two-factor with replication, without replication. But for the most part, we're going to be doing an ANOVA single factor. So just imagine you had these different clubs right here. Are these clubs basically, in terms of their variance, in terms of their average variances, are they equal or not? So we'll do data analysis, ANOVA single factor, then we'll press OK. All right. Then we'll put in, here is your data. But for me, I always like to include the label. So I would actually start from A1. Yeah. And include this entire data set. Make sure I got labels in my first row. And we're going to drop this, for example, at A8. Bam. All right. So once you do all of that and you press OK, all right, boom, got that data. Yep, drop it right there. Press OK. Splacker, you will have your results. All right. So right off the bat with the ANOVA single factor analysis toolkit that you have used, you're going to see that they're going to take all those numbers and be able to sum them up. Yeah. They're going to take all those numbers and be able to find the averages. They'll take all those numbers and be able to automatically find the variances. But what we're testing is, are these averages basically equal? All right. So the way to check it is two ways. Like we've always done with hypothesis testing, we can test with the test statistic and we can test with the p-value, the probability value. So what I'm going to do is I'm going to get my beautiful penmanship up in this piece. All right. I'm going to draw a line right here. All right. And you know how our data looks like a normal bell-shaped curve. All right. And once again, for the most part, this is going to represent a right-tailed test. All right. This is the rejection zone in the right tail right over here. All right. So how do you know if these are equal or not? If I'm eyeballing it, nah, they don't look equal. All right. But is there overwhelming evidence that it is not equal, that these three averages right here are not equal? All right. How do we look at it? All right. In the results, here is your F, and I will put stat, S-T-A. All right, it's hard to write with a mouse, A-T. All right, this is your F stat or your test statistical value. This is that dot that appears somewhere on the number line. Here is your critical value. So 3.89, I'm going to put it right here. 3.89. Yeah. This is your critical boundary. So the question is this test statistic in the rejection zone or not? If you were to look, it is at 25.2. Ain't it somewhere out yonder? Yay! All right, I'm going to use this golf ball. It just so happened to work out right. All right, I'm just guesstimating where 25 is going to be, all right, on this number line. So in essence, these three averages are not equal. At least one or more of them are not equal. Yeah, yeah. That is basically what these results are going to be able to tell you. You're looking at averages, one, two, or two, three, four, how many average you got, and checking to see are they equal or not. In this example, there's overwhelming evidence that it is not. That is the first test. Now, you can also look at the p-value test right here. If this number is less than or equal to 0.05, then you would say reject it. All right. 0 is less than or equal to 0.05. So therefore, it is in the rejection zone. The more you know. All right. So I'm going to clear this out. Hopefully that made sense to you. Erase all of that. Give me back my laser. All right. So what we're going to be doing is providing you the ANOVA where you can actually calculate it manually or use an Excel template. All right. We're going to show you how to do it with replication and also without replication with blocks. All right. So with replication is like if you go to a party and you win a prize. All right. And let's say your name goes back into the hat to win another prize. That's with replication. Without replication is once you win that prize, get on out of here, man. You do not get to put your name back in that hat. All right. You cannot be winning more than one prize. All right. So with or without replication, but ultimately, we're going to show you the formulas up here. You'll be able to enter your data down here and determine the test statistic and the p-value. Yeah, yeah. Let's get into it. If you would, please, would you open up chapters 13 in Excel, all right, within your Trello board. Let me go find my Trello board. All right. Once again, in the description below is where you'll find a link to the Trello board. So please click on the Trello board. All right. And what we're going to do is for chapters 12, we'll look for chapters 12 Excel. So grab it, click it, scroll down. You'll see chapters 12, actually chapters 13. Grab chapters 13. All right. We're going to open it up. Once it's open, please enable it. And once again, for our final exam, we will be using chapters 12, chapters 13, 14, and 15. All right. So there's going to be two questions that come from here. I'm going to make sure I let you guys know which two those are that will show up on the exam. So save it. Hopefully you got a nice desktop folder, BUS352. If not, just create a new folder. All right, I'm going to double click in there. Hey. All right, and then I'm going to save it. All right, so please save your Excel template. Once you have it saved, please open up Cengage. So I'm going to minimize that. I'm going to go once again for chapters 13. It could be anywhere between weeks 12, 13, or 14. Find it. All right, I'm in week 13 for my classes. I'm going to click it. All right, and I'm going to open up the assignment. Perfect. As this is opening, please, if you would, do a dual screen. So you know what we do? All right, for my Windows users, we just drag it to the right. All right, grab our Excel. All right, and if you would, please, can we please start off with 13.01? All right, so click through until you see 13, exercise 13.01. All right, perfect. So all we will do is grab our data. All right, we'll be able to find our mean. We'll be able to find our sample variance, and then we'll be able to get these answers right up in here. All right, so right off the bat, I believe we can copy this. Please do not include the means data. just stop right at this last number just above the sample mean values. So I'm going to copy this, single click, and I'm going to paste it. All right. And please note to self that it kind of shifts from the second row over to the right. So I'm just going to highlight this and shift it back over to the left. All right. Anywhere on this green line, you can click and then drag it over. All right. So please make sure you have your data and it is uploaded, downloaded, however you want to say it. But please make sure that your data is in there correctly. So just imagine we have 3 treatments, all right? A, B, and C. Are these treatments equal in terms of their averages or not? All right, that's what we're basically looking for. All right, so on here, I'm going to just highlight these 2, and on the bottom right, I'm going to drag it over so it keeps that same color. All right. And you can type in, let me see if it, nope. All right. I'm just going to do the first 3, copy, single click, paste. Yeah. Do the last 3, copy, single click, paste. All right. So on here, what we're doing is an ANOVA single factor. Yeah. So give me a second. Let me just pull this down just a tad bit. Good. So all we do is data analysis. And once again, if you do not have data analysis, all you have to do for my Windows users up here, type in add-ins. All right, if you click on it, please make sure that you have analysis tool pack selected. For my Mac users, you're going to see like analysis tools or something like that. Click it, and please make sure that you just select analysis tool pack. All right. So with that said, data analysis, and we're looking for ANOVA, the very first one, single factor. So scroll up, click on ANOVA single factor, press OK. All right. I'm going to press this up arrow or this icon to the right of input range. Start from A and end at your last number, please. All right. I'm going to press enter. All right. I'm going to have labels, and I'm going to drop this output right here. So for those of you who are following along, you can actually take a quick screenshot of this. All right, just make sure yours matches B2 to D8. All right, labels, output at H1, Hotel 1. All right, press OK. Override it, press OK. Smacker, you will have your results. So you can actually manually select and put them all over here, or we can just use this right here. So what I want us to do so we can get used to this is use this output right here. So I'm going to slide this over, make this over here. All right, so here is our ANOVA single factors output. All right, so they say compute the sum of squares between the treatments. All right, so let me make this just a tad bit smaller. I'll move this over. Give me a second. Nope, too far. All right, please note to self, this is your treatment, and this is your error. All right, so when they say the sum of squares for your treatment, that is that number right there. So I'm going to copy it. I'm going to paste it. And you know what I like to do? I like to yellowify it. All right, because that will show up in Cengage. Check your work just to make sure. Yes, sir. All right, we're good. Then we talk about the sum of square or compute the mean squared between treatments. All right, so here's your MS, mean squared between treatments. Please yellowify it. I'm going to copy it, paste it in there. Hey. Good work, good work. And then compute the sum of squares due to error. So we're going to yellowify this one, copy it, and paste it. Yeah. And also the mean squared for your error, due to the error. So I'm going to yellowify it, and they want 1 decimal place for this guy right here. So move it over. All right. And then you can copy it and paste it. Check your work, make sure you're good. Yes, indeed. So you guys can see where we're actually pulling information from. Then, good luck to you, good typing to you. Make sure you get this right. All right. They want all these values right here in here. So if I were you, hey, you better be on a copy paste kind of mission. All right. Copy, paste all these answers. All right. So for the smaller numbers, you can just type it in. It'll probably be easier. All right. But any kind of large number, you want to copy paste. All right. So for this guy right here, for your F value, round F to 2 decimal places, P to 4 decimal places. So I'm going to do it right now. I'm going to round it to 2 decimal places and then yellowify it. Remember, all of these are yellowified. Hey, let me do it right. All right, these two as well. All right, and your p-value, this guy is going to be 4 decimal places and yellowified. All right, check your work, make sure you're good. Yes, indeed. Then it goes on to say, right here, calculate the value of the test statistic. Please put a note up above F. This is your test statistic. Your F value is going to be always your test statistic. All right, so put that F value again. All right. So once again, this is a right-tail test. If your test statistic is 5.5 and your critical value is 3.68, isn't 5.5 greater than or in the rejection zone of 3.68? So you would say reject. Yeah. So your p-value was the p-value. Your p-value is between 0.01. All right, let's check to see if they did it right. Yes, indeed. What is the conclusion? If this number is less than 0.05, if it is less than, or let's say, or equals to 0.05, then reject. All right. So if this number right up here is less than or equals to 0.05, then reject. All right. So you can conclude. Check your work. All right. Outstanding. So let me see. All right. You can put all that stuff in here. So you can put between 0.01 and 0.025. All right, and then conclude. Dot, dot. Yeah. Please make sure that you understand where all of this stuff is coming from. So here you could have put equals to, let me maximize it and just click it, equals to L12. Yeah. That is your test statistic. All right, so that's all I would need from this example. Let's go to 13.05, please. All right, this will show up on your exam, so please make sure you get this one right. So I'm going to slide that over there. Please look for 13.05. Bam. All right. So up here are your calculations. We'll put in the numbers that they provide us in a completely randomized design, which is good. 12 experimental. So for the first treatment, 12. Second treatment, 15. Third treatment is 20. All right, so you got your data right there. And then they're going to provide you two numbers. Please plug them in, 1,400 and 2,000. When you plug that in, this entire box becomes yellow, and you can actually enter your data. Yeah, yeah. So good typing to you. Hey. And they want two decimal places for everything, but four decimal places for your p-value. All right. You see how my p-value is set to three decimal places. Please move it over to four decimal places, please, just in case. All right. So move it over, but in essence, mine is going to be equal to 0. I'm going to check my work. Outstanding. If my p-value is 0, which is less than 0.05, I would know that it should be rejected. So you can conclude, all right? But let me go for my p-value less than 0.01. Check my work. Yes. Conclude. Let me see. Cannot conclude that the mean of all three treatments. Look at how they will trick you. They are going to change the way they're describing this example right here. You cannot conclude that the mean of the three treatments are equal. So be aware of this. Let's put it in here. So this one is going to be less than. And once again, this is a test question. These should not change. All right. And then say cannot conclude dot, dot, dot. Yeah. And be aware, this is why we practice it. This is why we try to understand the way Cengage is asking or making their statements. And then from there, we can make informed decisions. All right, good work, good work, good work. Let's go to basically the multiple choice 13.006. Click through until you find it. All right, perfect. It says the ratio, actually in chapters 13, there will be 3 questions. All right, this is one of those questions that will be on the exam. The F ratio in a completely randomized ANOVA is the ratio of what? All right. Let me see. The mean squared for the treatment divided by the mean squared of your error. All right, I believe it is this one. Let's say mean squared of your treatment divided by the mean squared of your error. Check your work. Yes, indeed. Please make sure that you ratify your answer. This is going to be an exam question, so please make sure you have your answers ratified. All right, let's go to 13.09. Actually, I think I saw that like up here somewhere. Nope. Oh, right there. All right. Same kind of concept. We're looking at 50 degrees Celsius, 60, 70 degrees. All right. So we're going to grab this, copy and paste, single click and paste. Once again, it shifts it over. So just grab from the second row over and shift it back over. All right. And then on the exam, what they're going to ask you to do is an ANOVA single factor. Actually, let me look and see which ones will show up on the exam. So don't forget, in the PowerPoint itself, it tells you what will show up, 13.05, good. 13.06, good. And 13.15. All right, so now that we know that, let's go back into Cengage. Let's grab our Excel as well. All right, and we're going to do an ANOVA single factor. Data, data analysis, ANOVA single factor, please. Press OK. All right. Don't forget, your input is all your data points. Grab all of it, including the label. All right. Then press enter. All right. And we're going to drop this thing right at H1. All right. So pictify this. Make sure you're starting from B2, going all the way down to D7. And then ensure that you're dropping it. Where do you want to see the results displayed? H1. Press OK. Override it. Gimme, gimme. All right. So on this one, let's see, give me a second here. All right, let me find my Excel. I dragged it over too far. All right, here we go. Excel. All right, and let me grab my Cengage as well. All right, so on this one, they want all that information right over here. All right, and please be reminded that the between the groups is the treatment. The within the groups is your error. All right, so now that I have that, I'm going to smallify this just a tad bit. So I got my treatment, I got my error. All right, so good typing to you on this. Please type it all out. Make sure everything is right. Um, 45. All right, and they want 2 decimal places for everything else, but p-value 4 decimal places. All right, so I'm gonna do this, set these to 2 decimal places. Perfect. I'm gonna set this one to 4 decimal places. Perfect. All right, and I'm just gonna copy and paste. All right, so right off the bat, is this number less than 0.05? In my mind's eye, no, it is not. So therefore, just from my probability value, I can say and determine that this is a do not reject. In other words, all of these temperatures, the averages are basically equal. There's no overwhelming evidence that they're not equal. All right. So I've typed all of that stuff. What is my test statistic? Don't forget your test statistic is your F value. Perfect. All right. So my F value. All right. This guy is going to be 0.1. All right, greater than 0.1. And the conclusion is do not reject. All right. Hopefully this one was worded correctly. All right. On that one, it was worded correctly. So please don't get caught up with the okey doke. I didn't read through it. I'm sorry, but please make sure you take your time to read why what they're saying is the answer that they provide. Yeah, yeah. Figure it out for yourself. All right, but those drop downs, just get it right. All right, let's go to 13.12, please. All right, 13.12. Up, I never checked my work on this one. Perfect. All right, here's 13.12. All right, we're dealing with food, restaurants. So basically the prices of different restaurants. So in your mind's eye, do you think that Italian food, seafood, and steakhouse, they all are equal in the price you pay at the restaurants? Or do you think that one will be more, one or more of these are going to be more or not equal to the rest? All right. So if you don't know it, just grab your data, copy it, paste it, single click and paste. All right. So what they did was they shifted everything a cell over. So I'm going to move this one over. Let me smallify it so you guys can see this. And I'll move this one over. All right. So we got Italian food, yeah, which averages about maybe $15. Seafood, which averages about, yeah, if I were to guesstimate, $16. And then steakhouse, which averages about maybe $23. All right, that's just my eyeball averages. But we can actually do a data analysis, single factor, press OK. All right, give me all my data stuff, include the label. All right, and we're going to drop this output at H1. Press OK, press OK, and say gimme, gimme. All right. So once again, for my averages for Italian, $17, good. $19 for seafood, and $24 for steakhouse. Yay! All right. So on this guy, I'm going to slide this over right here. Slide this over. Don't forget the between the groups are the treatment, and the error is the within the groups. So once again, good type into you. I believe they want whole numbers for these. So I'm going to move these over to whole numbers. Good. Degrees of freedom is whole number, 2 decimal places for these. All right, I'll move those over to 2 decimal places. Good. And your p-values, always for the most part, is 4 decimal places. All right. So once again, good typing to you. Make sure you type it in there correctly and make sure you're good to go. All right, and then put in your p-value. All right. So right off the bat, since my p-value is 0.0064, isn't that less than 0.05? Yes. So you would reject. What that means is that all of these, they're not equal. As you can see, steakhouse, you're spending $24 for your steakhouse. Yeah, $24 on average for your steakhouse. All right. So the p-value is going to be less than 0.01. Yep. And the conclusion is, all right, once again, cannot reject the assumption all treatment means are equal. Conclude not all treatment means okay. So you got to read through this and try to make sure that you get it right. But get it right, get it right, get it right. Wrap your brain around however Cengage is posing it. All right, let's go to 13.15, please. This is going to be on your exam, so please make sure you get this one right. All right, that's my last one. All right, same thing. We'll grab the data, copy it, we'll paste it. All right, it's shifted, so we'll shift it back. All right, that's how real life is. Sometimes the data comes over cleanly, sometimes it doesn't. You have to adjust accordingly. So on this one, we'll do an ANOVA single factor again. So data analysis, ANOVA single factor, press OK. All right, I'm going to grab my new data. All right, and I'm going to drop it right at F1 in this instance. All right, please make sure that you're dropping it right here because all these calculations below match up identical to if this output is dropped right here. So please make sure that you drop your output right here. Press OK. All right, bam. You should have 4. You should have 4.88 for your MSE. All right. And you should have your Fisher's LSD at 3.54. All right. So let's go into this, make sure that we got them all right. What is your sum of squares for treatment? Once again, if I were you, I will put treatment and I will put error. All right. Good. Sum of squares for the treatment, put equals to and click it. All right, sum of squares for your error, put equals to, and click it. Mean square for your treatment, click it. Mean square for your error, equals to, click it. Your F value, put equals to, click it. All right, and your P value, put equals to, click it. Way down here, K12. All right, now these right here, select all of these right here, all the way down to F. We're going to set these to 2 decimal places. All right, so set it to 2 decimal places, please. This guy right here, we're going to set to 4 decimal places. All right, so move it over. All right, so what I'm going to do, when you see e to the negative, it means move the decimal places, in this example, -6, 6 places to the left. All right, so if you see e to the negative, whatever number, let's say it was 4, you move the decimal places 4 places to the left 4 places. All right, but let me see how I can actually do this. to change it to, all right, give me a second. I'm just going to use these two right here. That's going to mess that up. I'm just trying to get my regular number. Let me undo that. Give me a second. All right. So what I'm going to do with this, I can't remember how to just change it. Just change it to a general number. Maybe a number. All right, good, good, good. Change it to a number and then move it over 4 decimal places. Wrong way. All right, good. So if you change it to a number, it will get rid of the scientific numbering, if that makes sense to you. All right, so I got that. And because it's 0.0, which is less than 0.05, this should say rejected. All right, well, let's see what Cengage has, and we're going to make sure we match it up accordingly. So I'm going to bigify this just a tad bit. All right, I'm going to copy and paste. All right. This is your test statistic. All right, your p-value is less than 0.01, and the conclusion should be conclude that the mean time needed to mix a batch of material is not the same for all. All right, because it says rejected, I'm going to put that. Let's check our work. Outstanding. Let me smallify that. Yep, good, good, good. So on this last one right here, just put conclude the mean, dot, dot, dot. All right, and this guy is also going to be less than 0.01. All right, so make sure that you got proper notes in there. And then it says, can you provide the Fisher's LSD? And which Fisher's LSD? Between 1 and 3. So I'm going to maximize this so we can see this a little bigger. Between 1 and 3, they want the Fisher's LSD. So I'm going to yellowify just this middle one right here. And it's going to say significant. Yeah. So these two results is what we're looking for next. So in here, I'm going to put, let me grab it, slide it back over here. All right, 3.54. It is always going to be 3.54. All right, and it is significant on my end. These manufacturers have different mean times, cannot conclude. So I would say they have different. Let me check my work. Yes. So if it's significant, all right, if I were you, I'll put a note to self. Sig equals these manufacturers, dot, dot, dot. All right. And not significant equals, let me see what other one, cannot conclude. All right. Help you, put a note to yourself, and let's get this right. All right, 2 more to go. Let's go to 3.17, please. 3.17. Yeah, don't remember which one it was. All right, not that one. All right, same kind of concept. Copy your data. Hopefully this paste, yes, that paste in there correct. We'll do an ANOVA single factor, data analysis, ANOVA single factor, press OK. All right, so I'm gonna make sure I get all my data, including the label, and I'm gonna drop this at F1. Bam, press OK. All right, bam, there's your numbers. All right, I'm gonna drag this over and let's go to work. Your sum of squares for the treatment. Sum of squares for the error. All right, and your treatment. Your mean square for the treatment. your mean squared for the error, your test statistic, and check your work just to make sure you got all that stuff done right. Good work. Your p-value, do you see e to the negative 0.7? What that means is move that joker 7 places to the left. So in essence, this number is 0. So it's going to be less than 0, and you conclude that these means are not all the same. All right, just so you guys can see this. Yes, indeed. Your Fisher's LSD, if you scroll down, all right, is this number right here, 0.87. All right. And then how do you find your differences? If you scroll over, these are your differences right here. All right, so you type those in, check your work. Outstanding. And which answers is correct? If you go to the far right, they're all significant on my end. Once again, I'm not sure if they did this right, but I will do significant, significant, significant. Get it, get it, get it. Yes, sir. Let's go. Uno más. One more, one more, one more. 13.23, please. All right. So simply just plug in what they provide you. 1,000, 600, and 2,000. All right, good. Your degrees of freedom. Um, let's see. Give me a second. All right, the p-value of that. Let me make this bigger so I can see them all. Great, 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 great. All right. An experiment has been conducted with 4 treatments. All right, this first one is your treatment. So you will put equals to 4 minus 1. All right, K minus 1, that's your treatments. Equals to, with 8 blocks, equals to 8 minus 1. All right, just double check, make sure that that's right. That times that, good. Make sure that these is the sum of all 3, good. All right, and then you should have everything that you need. All right, and for the most part, these are going to be 2 decimal places. Let me move them over. Outstanding. All right, your F's value is 1, good. And please make sure that these are set to 4 decimal places. Move them over. Make sure that you're good. All right, so once you have all of that, and because this is 0, I would say cannot, or you can conclude that not all treatments are equal. My p-value is less than that. Just check your work just to see if you're right so far. Yes, yes. All right. And good type into you on this. All right. So we got 400, 3, 7, 31. Good. Take your time, plug them in, make sure that they're right. All right. Which F value do you use? The top one. All right. And then a p-value of 0. Check your work. Yes, indeed. Once you're done, please submit for grading and you should be good. So you should see that ANOVA looks at different groups and subgroups to determine, man, are these groups equal, or is there overwhelming evidence that one or more of these groups are not equal? We can actually calculate it using an ANOVA hypothesis test. That's all I got for you. Have a great day. See ya.